We are going to spend section 13.3 looking at exactly one topic, the Pythagorean theorem. So this is such an important concept for right triangles that it shows up in many applications. See, in any right triangle, we know that the sides, or the legs, if we label them A and B, it will always be the case that the square of the length of the hypotenuse will equal the sum of the squares of the lengths of the other two sides. If you've taken a geometry class before, you probably have seen a squared plus b squared equals c squared. And all that is saying is that you have some side A and another side B, and you square those, a squared and add plus b squared, you'll always get the hypotenuse squared. Let's look at a few examples of how this Pythagorean theorem is used to solve problems. So first, we're going to draw a right triangle where the right angle is at angle C. Then our angle A and angle B can be at either of the remaining two vertices. AC, which is going to be the segment between points A and C, is given as 5, and BC is given as length 12. Here we have two of the legs. Now, it doesn't really matter which side you say is A and which side you say is B, because you're adding these two values. And addition, it doesn't matter what order you're in. But typically, the label that we would give the side across from an angle is going to be little a. And that's because across from angle A would be that side. And then across from angle B would be little side B. But again, these are not necessarily the A and the B that show up in the Pythagorean theorem. Those A and B is just a way to label the two legs. So don't get too confused with or be too rigid with the way that you label these. Just make sure that you know whether it's a side length or if it's a hypotenuse. In this case, though, in example 1, we are looking at the two legs, and so we'll say 5 squared plus 12 squared will equal the missing hypotenuse squared. 25 plus 144 will equal c squared. That gives us 169 equal to c squared. To solve this, we take the square root of both sides, and c is equal to 13. Let's do a few additional problems. So we're going to draw a right triangle with the right angle at C, and we'll have side A across from angle A, side B across from angle B, and side C across from the right angle. In part A, we're given that side A is 4.0 and side B is 8.0. Using Pythagorean theorem, we have the two sides, 4.0 squared plus 8.0 squared equals c squared. That's 16 plus 64 equals c squared. And when we add 16 plus 64, we get 80. So 80 equals c squared. You take the square root, and here the square root of 80 is a long decimal, and so we'll keep with the rest of the measurements having one decimal point, and so this one would be approximately 8.9. Now for part B, we're given that side B is 21 and side C is 36. This time we're missing one of the legs. So we'll leave a squared and we'll add 21 squared, and this time it'll equal 36 squared. 21 squared gives us 441, and 36 squared is 1,296. Now to solve this, we will need to subtract 441 from both sides. That gives us 855. And then finally, we take the square root, and the square root of 855 is 29.2, which here we would probably either round that to 29 or keep it at 29.2. And then finally, for part C, we know side A and we know side C. So we know one of the legs and we know the hypotenuse. So here we have 14.2 squared plus B squared equals our C squared. 14.2 squared gives us 201.64. And 20.7 squared is 428.49. So let's subtract 201.64 from both sides. And that gives us B squared is equal to 226.85. Finally, we take the square root of both sides. And B is approximately 15.1.